Question 20. The table shows the future value for an annuity of $1 for varying interest rates and time periods. Part A. Ken invests $200 at the start of each year for 8 years at an interest rate of 5% per annum. Calculate the future value of Ken's investment. Firstly, we need to identify the correct interest factor from the table, and we need to use the information given in Part A. Ken invests $200 at the start of each year for 8 years at an interest rate of 5% per annum. So that's compounded once per year or compounded annually. So it's 8 years, which means we need to use row 8 from the table, and it's 5% per annum, so it's the 5% column. And where the row and the column meet, the correct interest factor is 10.0266. So to find the future value of Ken's investment, we take the interest factor that we just found, multiply it by the amount that Ken is investing each year, that's $200 per year, and we get a future value of $2,005.32. Part B. Shay is planning to take a holiday in 3 years. She needs $4,500 for this holiday and will make regular 6 monthly payments into an account that earns interest at the rate of 4% per annum, compounded 6 monthly. What is the minimum amount Shay needs to pay into this account every 6 months? Give your answer to the nearest $10. Support your answer with calculations. From the information provided in the question, Shay needs $4,500 for this holiday. So that implies a future value of $4,500. So in contrast to Part A, where we're asked to find the future value, in Part B, we're given the future value, even though it's not explicitly stated, it's implied, and we want to work out the value of each investment so that the future value after 3 years is $4,500. So reading on, the payments are regular 6 monthly payments into an account that earns interest at a rate of 4% per annum, compounded 6 monthly. So we want the interest rate per 6 months. So we take 4% divided by 2, since 6 months represents half a year. So the interest rate is 2% per half year. Now the total number of compounding periods is 6. Since there are 2 compounding periods in 1 year, there's 2 half years in a year, and it's over 3 years. So 2 times 3 gives us 6, so we have 6 compounding periods over a 3-year period. Next, we need to find the corresponding interest factor from the table. Now, I've written that here, 6.4343. Let's go back to the table and work out how to locate it. So we want the 2% column, and row 6, since that represents the number of compounding periods over 3 years. And we get this interest factor here where the row and the column meet. So 6.4343, and that's our interest factor. So to work out the value of each investment, we do the reverse of what we did in Part A. So we take the future value and we divide it by the interest factor that we just found. So 4,500 divided by 6.4343 gives us 699.37677 and so on. But the question wants us to work out the value of the investment correct to the nearest $10. So that's equal to $700, correct to the nearest $10 every 6 months.